The content which I am going to cover are forgery detection approaches, methods in digital videos and its categories, artificial intelligence, machine learning, deep learning, impact of machine and deep learning algorithms on visual forgery, tools and datasets utilized in detecting visual forgery, various performance matrices among visual forgery detection techniques, effects and future outlook of techniques for detecting visual forgery, some discussion on machine and deep learning, then conclusion and then references. Now, introduction. Image forgery means manipulations of the digital image to conceal some meaningful or useful information of the image. There are cases when it is difficult to identify the edited region from the original image. The detection of a forged image is driven by the need of authenticity and to maintain the integrity of an image. A digital image can be forged by various attacks like rotation, scaling, resizing, addition of noise, blurring, compressing, image splicing, copy move, etc. Now, image forgery detection is further categorized into two categories, which is active and passive approach. Digital watermarking and signature comes under active approach. Forgery dependent and independent comes under the category of passive approach. Forgery independent is further categorized into image retouching, whereas forgery dependent is categorized into image splicing and copy move forgery. Now, there are some video forgery techniques which are spatial forgery and temporal forgery. Spatial forgery is also known as interframe forgery. Copy moves, image splicing and upscale crop comes under the category of spatial forgery, whereas in temporal forgery, which is also known as interframe, is categorized into frame insertion, frame deletion, frame duplication and frame shuffling. Now next comes artificial intelligence. Artificial intelligence is superset of machine learning and deep learning, or we can say machine learning is subset of artificial intelligence and deep learning is subset of machine learning. Now, further machine learning is categorized into three categories, that is supervised, unsupervised and reinforcement learning. In supervised learning, data is labeled. In unsupervised learning, data is not labeled. And reinforcement learning depends on penalty and reward system. Now here comes the general framework of deep convolution neural network. In this we take an input image, then various convolution layers are applied on the input image. After that pooling is done and layers are then flattened to extract an output image. Now, impact of machine and deep learning algorithms on visual forgery. Machine and deep learning algorithms have simply impacted the field of visual forgery detection. Visual forgery refers for creating or manipulating digital image or video to deceive or mislead viewers. Applying machine and deep learning techniques in this context has enhanced the ability to detect various forms of forgery, including image manipulation, deepfake videos, and other type of visual misinformation. Now comes tools and datasets utilized in detecting visual forgery. Detecting visual forgery involves using various tools and datasets, often employing traditional image processing and machine learning methods. Tools which are used are Adobe Photoshop, image forensic software, ImageJ, MATLAB, deep learning frameworks, camera identification tools, and datasets like uncomplexed color image database, Confog, Columbia database, ImageNet, which are used. After that, various performance matrices among visual forgery detection techniques. Visual forgery detection techniques are crucial in identifying manipulated or forged images or multimedia content. Here are some key matrices used in assessment of visual forgery detection methods. Like, if we talk about accuracy, the ratio of correctly classified instances to total number of instances. Then comes precision, is the ratio of true positive to the sum of true positive and false positive. Recall is the ratio of true positive to the sum of true positive and false negative. FI score is the harmonic mean of precision and recall. Area under the receiver operating characteristic curve is a matrices that assess the model's ability to discriminate between authentic and false instances across different threshold values. The raw curves plots the true positive rate against the false positive rate. After that, next is area under the precision recall curve, which is similar to OCROC but focuses on the trade-off between precision and recall, which measures the precision recall curve, providing insights into the model's performance across various decision threshold. After that, confusion matrix come, which is a table that represents summary of model's performance including true positive, true negative, false positive and false negative. Then comes mean square error for localization, which can measure accuracy by comparing predicted and ground truth box coordinates. Now comes effects and future outlook of techniques for detecting visual forgery. These techniques plays a crucial role in identifying manipulated or tampered images and ensuring the authenticity of visual content. The effect of visual forgery detection techniques are profound, contributing to trust mitigation, mitigating misinformation and impacting legal outcomes. The future outlook involves technological advancement, increased integration with other technologies like blockchain, and focus on real-time detection and interpretability. The field is expected to evolve to keep pace with emerging threats and challenges in digital landscape. Now, here is comparative study of various papers. Like in first paper, rectangular neural network and convolutional neural network layers are integrated and compact and acute skin data sets are used to validate the effectiveness. Here, integrated RL layer in the skin detection algorithm is used. After that, next inspection of tampered video clips, validation technique is used, and validation is done on 6 data sets. Accuracy is achieved 98.89%. In next paper, frame deletion detecting technique is used. Here, true positive rate reached 90.12 and false positive rate reached 7.71. In next paper, sequential and patch analysis technique was used, and SISU object forced dataset is used. Here, robust results for tampered videos and low computational complexity. Conclusion: the effectiveness of digital image editing, fueled by advances in computing technology, has fundamentally changed how information is shared and accessed. Internet as a platform, social media and visual data continues to grow rapidly. Requirement for authentic method for identification of tampered as well as visually forged has become very crucial. Now machine and deep learning techniques have become very powerful tool which helps in detecting forged and tampered data. These machine and deep learning techniques excel at uncovering precisely altered features within images. As there is a tremendous advancement in technology continues, the need of an strong collaboration between researcher, industry and policymaker will be required in staying ahead of emerging forgery techniques and mitigating their potential harm to credibility in the era. Here are the references which I have used cited during my paper. Thank you so much.